in the footsteps of Jesse Owens. Usain Bolt has the least to fix based on his first 3 rounds. The gentlemen to his right have to summon something great to be able to compete with Usain Bolt tonight.
Set.
There's the start, and Bolt got a good one, and Gay's right with him, and so's Asafa Powell. Bailey's there too, but here's Bolt. Bolt charging to the front. Gay's coming, but can't catch him. Usain Bolt, look at the time, 9:58, world record.
Welcome to this presentation. My name is Mark Scythian. The date today is December 21st, 2024. So this presentation is going to focus on Usain Bolt, his horsepower and metabolic data. So this is relevant to Usain Bolt, the Olympic world record holder for the 100-meter dash, 9.58 seconds, and that was in the year 2009, and so far undefeated. So we look at the weight of Usain Bolt in 2007. Prior to the start of the 100-meter dash, it was 207 pounds, so that's 94.1 kilograms. Distance 100 meters or 328 feet. Time 9.58 seconds. Acceleration 1.09 meters per second squared. Propulsive or dynamic force 102.6 newtons. The power involved 1071 watts of metabolic power output, mechanical. So his horsepower would be 1.44 horsepower. We know that human metabolic efficiency is 95%. Human resting metabolic rate is about 0.07 calories per second. So the glucose metabolic equation is C6H12O6. This is 1 mole of glucose requires 6 moles of oxygen gas, and that then breaks down into caloric energy. And then we can't create or destroy matter, we can only change its form. So then 1 mole of metabolized glucose then breaks down into 6 moles of carbon dioxide gas and 6 moles of water. So we convert calories per second to watts. It's 1 calorie per second is equal to 1 calorie per second is equal to 4.184 watts of power. And so if we take 1071 watts and divide it into 4.184, Usain Bolt is burning 256 calories per second over the 9.58 second run. So that's a total of 2458.5 calories output. And so the glucose molar mass is 180 grams per mole. And so the energy density of glucose / carbohydrates is 4 calories per gram. So calories per mole, there's 720 calories of potential energy in 1 mole of glucose. And so if we quantify the moles of glucose consumption, including resting metabolic output, this is 3.410931 moles of glucose were expended during the 9.58 second run on the 100-meter dash, Usain Bolt. So the total oxygen consumption, oxygen is 21% by composition of air, 78% of air is nitrogen, and 1% is inert gases. So if we solve for the molar differential, we then calculate 0.72 pounds of oxygen gas. And then the total air consumption, or the inhaled air, is a function of the 21% differential inverse of the oxygen intake. So that becomes 3.4 pounds of air, or 1559.6 grams of air. The carbon dioxide output respirated after burning 3.410931 moles is approximately 2 pounds of CO2 gas. We know that there's 44 grams per mole to carbon dioxide molar quantity. and then a required total caloric intake at 95% metabolic efficiency, 1 over 0.95, the reciprocal is 2588 calories, were then broken down into 2458.5 calories output in the form of kinetic energy, so it'd actually be calories per second, but we quantified 256 calories per second for 9.58 seconds, so a total of 2458.5 calories were put into actual yield of caloric output. But at 95% metabolic efficiency, it would require 2588 calories of food consumption in the form of glucose. So then the final registry of specifications include the Usain Bolt 100 meter dash horsepower, power, and metabolic data, and these have been converted to US units for simplicity, except for the calories output, because that's the common units of food power output in the United States, even though technically it should be BTUs, food BTUs, but 252 calories to a BTU, but the standard here in the United States is one of the only metric units is calories, and of course millimeters blood pressure, even though it would be, you would think it would be in PSI, but anyway, these are the final specs. So Usain Bolt, 207 pounds weight, runs 328 feet in 9.58 seconds. That's an acceleration of about 3.6 feet per second squared, a dynamic horizontal propulsion force of 23.05 pounds force, total power or power output 1071 watts, equivalent horsepower 1.44 horsepower, inhaled air 3.4 pounds mass air, total oxygen consumption 0.72 pounds, carbon dioxide gas inhaled, carbon dioxide gas, actually it should be exhaled carbon dioxide gas 2.0 pounds, glucose consumption 3.41 moles, calories expended 2,458.5, but technically the total food calories expended 2,588 calories, all over a time span of 9.58 seconds. Thank you for watching this presentation, and have a great day.